Hello everyone. Today presentation is given by Manoj Mandava and Sairandi Reddy Gopu, and our topic is based on the classification of sign language for deaf and hard hearing people, where this project is dedicated to build a model that is capable of a sign language classification. This model may work as a bridge for deaf and hard hearing community. People with disability like autism, apraxia of the speech, etc., may also get hopefully benefited by it. We are trying to work it out by using a deep learning intelligence. CNN has been widely used for image classification models, and we are hoping it may benefit us here also. Deep learning has proved itself a powerful tool in the image recognition and the classification, audio classification, etc. We have we hope that right deep learning model may solve this problem with a good accuracy. Since we are thinking of using a deep learning model and the training seems to be very important here. For this, we are looking for a various data set, and we will get the right data from for our model. For our model, the training and validation, we use the Python and PyTorch TensorFlow.
The tasks faced while doing this project is there are many challenges. There are many challenges involved in the task and must be recognized with the plan of execution. Like we face the task like a hand gesture identification from the background, data accumulation by using different backgrounds, model hyperparameter learning in case of existence of trade-off, building the deep learning models and training the model by using right loss function and validation of model, and at the last finding the good accuracy. Like the problem statement is a lot of research and development in the field of computer vision has been developed by using Difflefy the solutions for deaf and hard hearing problem and dumb people communication. Many solutions are developed on the application of deep learning in computer vision to solve this problem at some extent. This project may play a vital role in building the gap for those people with the world outstand as the sign language is not popularly used. Further, this project may be finding applications in developing auto editors which comprehenses these hand gestures into the language which commonly spoken.
Where nowadays a recognition of sign language has emerged as a growing area of research. Several research papers aims at hand gesture recognition by pre-processing and segmentation features, extraction and recognition, conversion to text. We have found the many research papers have used different kinds of data sets, including like minis data set, and we also searched for a few of the popular blogs which aims to build its own data set and thereafter doing the image augmentation techniques by importing the image data generator using the Keras and the pre-processing or an image. It also have been observed that many of the image segmentation tasks become much more easier to use. We have convert the image and the morphology or the binary images. Further, the research papers of various regions aims to solve the regional based sign language recognition problem. However, we have found the many research papers are subjected to solve the American Sign Language recognition problems, as the ASL serves as a major sign language of this community is not only in US but also in some of the major regions of Canada too. We have hope the a proper CNN may do the task if we implement like correctly. We're coming to the dataset finalization.
Like data set we used is it was found it can be done by building our own data set and therefore using image accumulation by changing backgrounds and rotation and scales, etc. We made our model do live recognition on screen using OpenCV commands. Till then, we aim to work on M8 Science language dataset. This dataset is quite popular and many research papers mentioned it for the training and testing part. This dataset consists of 27,445 images of dimensions with size of 28 into 28 for hand gestures. This is also referred to as an American Sign Language dataset images. In the dataset belongs from 0 to 25 representation. This denotes alphabets in English literature A to Z, but may not be in a sequential order, but it consists of all the alphabets.
And coming to the approach that we have used to solve, we have tried to work it by using the deep learning intelligence, and deep learning has proved itself as a powerful tool in the image recognition, classification, and audio classification. We have thought that a right deep learning model may solve this problem with the good accuracy. And the CNN has been widely used for the image classification models, and we try to avail its benefits here also. Where in the deep learning approach, for the classification models, the cross entropy loss is widely used for the general activation function being like ReLU. And the batch normalization is also supposed to be applied in order to expedite the convergence and making the network stable. The max pooling has also been deployed. However, we have observed a many advancements in the max pooling development. We stick to the basic one, where we can see here the deep learning pointers for the ReLU activation function, which is like R of z is equal to max 0.z, and here is the graph for that. Where the deep learning pointers, which is like the convolution, basically used a filter and tries to correlate the filter with the image available. In the deep learning approach, we tend to find the entries to the different filter during the training operation. The entries are updated every time during the back propagation in the neural network. The max pooling is used to find the maximum correlation between the convolution with the filters to mark the region of interest. The dropout majorly finds its applications in the overfitting of the curve by dropping.
Building this model, this problem seems to be quite durable with the deep learning approaches using convolutional neural network. The CNN model may be used to establish image correlation with the reference numerical representation. Along with the several CNN layers, a flattening layer, a batch normalization, and max pooling layer may be deployed. We are in the favor that more better accuracy can be achieved with the much deeper networks. Regarding this filter size for CNN and layer stack, we are used some analysis and experiments. Regarding optimization, we used the deploying stochastic gradient descent with learning rate of 0.01. For loss functions, we deploying cross entropy loss, and we used ReLU activation functions to avoid gradient collapsing during back propagation. Hyperparameters involved in this time of training and learning rate of SGT and etc. and some more. Directory for this training and testing is divided in ratio of 8:2, and this is a deep learning architecture. Like we first give the images of size of 28 into 28, and then CNN algorithm done on it, and it then takes to ReLU, and then batch normalization and max pooling. Then the images convert into the less size, then again CNN, and we do the dropout and again ReLU, then converted, then again we use a batch normalization and max pooling, then again it is converted into the 3 into 3 into 25 size, and it is reduced to the size of less, and again we use batch normalization and max pooling, and then now we have flatten the images and dense, and we used again dropout and dense, then classification has been done on the images. Is it done on the single images, and then continue with the everyday.
And we can here see the observations for the accuracy plot with the training and the validation. And here's the observation, the graph for the training and validation loss for the sparse categorical and the cross entropy loss plot, where we are currently using the both TensorFlow and PyTorch for the parallel understanding of easy to use. We have found the PyTorch has been like much easier to with the respect to the TensorFlow libraries. For the PyTorch, we are using the torch is called the 1.2.0, and the torch version is called the 0.4.0. The model we are currently building is compatible, like we have built, like is compatible with Python 3.4 and the later versions. For the NumPy, it's been like a 1.114, and on an ONNX library, it is like 1.6 or later. For the TensorFlow version, it's like 2.0.0. The Keras is 2.3. These libraries are much easier to install using the pip install command. Although few research works from the research we have done in the MATLAB, we still hope that the Python is much more favorable to image processing tasks because of its libraries, where here we can see the observations as we said, the environment we set, where we can see here a converging accuracy of validation dataset with the training datasets as the number of epochs increases, and validation accuracy converges more than 90%. Same is the case of loss function convergence of dataset. The loss function for the validation datasets converges slowly with the training dataset's loss function, where the architecture finds problem in the classification between letters like J and Z, etc., where we can see the problems which we face. Like the major problem we got is to build the deep learning architecture, and the dropout rate is like hyperparameters, like it is very high and needs to be like carefully thought to, so that the overfitting problem may be avoided. Finding the right parameter was a challenging task, and coming to the future and relevance, we have been had there was an as we said, like there was a hyperparameters, like the dropout rate has been increased, and the apparatus has been used to which can be fine-tuned for the more better accuracy, and several research papers on this advanced max pooling may be deployed for the better accuracy, and we can see then an automatic editor may be developed out for this model for helping out this communicate. So this is our project presentation. If you have any doubts, please let us know. Thank you.
This is our code. We used CSV, Kernels, NumPy, and MATLAB, and we have used the TensorFlow also. Then this is the training images training size we have used, and the 27,455 images we have used, and the testing shape is of 7,172 images.
Where we can see the TensorFlow has been executed successfully, and here is the accuracy for the like 0.91 and several accuracy between the images. Thank you.
Thank you.